Welcome back, everybody. We are continuing our point 4 on factoring polynomials. And today we're going to talk about factoring trinomials. So there are several ways of factoring that we have learned throughout the years. If you already have a method that you absolutely love and is accurate, then please go ahead and make sure that you use that. I'm going to give you some alternative of a method that always works, regardless of if you have a trinomial with an a value of 1 or a trinomial of an a value greater than 1. It doesn't matter. This diagram shows you that this on the left is factored form, and this on the right is the polynomial that started it. So if you factor the polynomial, you get what's on the left. If you FOIL, distribute, however you multiply the terms on the left, then you would get the resulting trinomial on the right. One of the biggest things that you can do for yourself before you ever start factoring anything is to always check for a greatest common factor first. Always check for a greatest common factor first. I'm also going to give you a way to use the graphing calculator to help you with factors. All right. So starting with example 3a, 4, 11, and 6. Do we have a greatest common factor? And in this case, no, we do not. So 4 times 6 is positive 24. We need two numbers that will multiply to positive 24 and add to negative 11. So here's where your graphing calculator can come into play. In your graphing calculator, go in to the graphing section right along the top screen to Y1. Make sure all of that stuff is cleared out. Since we want positive 24, then we want to type 24 divided by x. Then go to the table. On your table of x and y are going to be values. Some of them are going to be decimals and some of them are going to be whole numbers. Because we want a negative 11, we're going to focus on the negative part. So you would have negative 1, negative 24, negative 2, negative 12, negative 3, negative 8, negative 4, negative 6, and then so on. Again, some of them are going to be decimals, but basically what you're doing is this table, if they're whole numbers, they are numbers that multiply to 24. So your job is to say, okay, which of those will add to negative 11? Negative 1 and negative 24 add to negative 25. That doesn't work. Negative 2 and negative 12 add to negative 14. That doesn't work. Negative 3 and negative 8, yep, they add to negative 11. So the two factors that we want to use are negative 3 and negative 8. Negative 3 times negative 8 makes a positive 24. Negative 3 plus negative 8 makes negative 11y. We're now going to make this look like a factor by grouping problem. To do that, we drop the first term. Whatever the variable is here in the middle, we put that with our negative 3 and our negative 8. Negative 3y minus 8y, because if I were to combine those like terms, I'd get negative 11. And then drop that positive 6. Split them in half. Our greatest common factor on this left side is y. When I divide these two by y, I'm left with 4y minus 3. Our next part starts with a negative. Our common factor between 8 and 6 is 2. Remember, that means we're dividing by negative 2, which is going to change signs here. So negative 8y divided by negative 2 is positive 4y. Positive 6 divided by negative 2 is negative 3. We now have our new greatest common factor of 4y minus 3. Pull those out, we're left with y minus 2. And this is factored form. Now, some of you are going to say, well, what if I put the negative 8 first and the negative 3 second? Well, that's okay. Let me show you. 4y squared minus 8y minus 3y plus 6. Our common factor over on the left side will be 4y. 4y squared divided by 4y is y, minus 8y divided by 4y is 2. That part starts with minus. Our greatest common factor between 3y and 6 is 3. Remember, it's negative 3, so we're dividing by negative 3 there. Negative 3y divided by negative 3 is positive y. Positive 6 divided by negative 3 is negative 2. Y minus 2 is our new GCF, so that's what we are writing down. The leftovers, 4y minus 3. So we got the same thing, we just got it in a different order. But, 4 times 3, 3 times 4, they're both 12. And that same thing applies here. All right. So 6, 7, and 5. Is there a greatest common factor for 6, 7, and 5? Nope, just 1. And in this case, the 1's not going to help us. So 6 times negative 5 is negative 30. We need the factors of negative 30 that will add to negative 7. So again, in your y1, now you would do negative 30 divided by x, and then hit the table and see what values you have there. And in looking at the values, that would be a negative 10 and a positive 3. Negative 10 times positive 3 is negative 30. Negative 10 plus 3 is negative 7. Bring down 6p squared. This is a p to the first, so minus 10p. That's a positive 3, so plus 3p. And bring down that last term of minus 5. From here, we're splitting in half. Our GCF on the left side is going to be 2p. Leaves us with 3p minus 5 plus 3p minus 5. Well, the only thing that's common is a 1. And remember, when we're doing factoring by grouping, you have to always pull something out, even if it's 1. Dividing those by a positive 1 does not change anything, but that's okay because we see that 3p minus 5 is our new GCF. And when we pull those out, our leftovers are 2p plus 1. And so this is our factored form. Two, 13, and 18. Well, the 13 is a prime number, so I'm not going to be able to find any factors there. 2 times negative 18 is negative 36. All right, so in this case, on our table, we go back to that y1, and we have negative 36 divided by x. We need something that will multiply to 36, and negative 36, sorry, and add to positive 13. All right, so on our table, we have -1 times positive 36, -2 times positive 18, -3 times positive 12, -4 times positive 9, -6 times positive 6. That's going to be 35, 16, 9, 5, and 0. I don't have anything that works. And so if I can't find anything that'll factor this correctly, then this is a prime polynomial or a prime trinomial. All right. Last but not least, we have this letter D. And remember we said we always check for our greatest common factor first, which we've talked about for all the other three. But this time when I look at 16, 24, and 16, I have a greatest common factor of 8. And then they all have a y. So I'm going to pull out a y. 16 divided by 8 is 2. I have 3 y's. I'm pulling 1 out, so 2y squared plus 24 divided by 8 is 3. 2 y's, pull 1 out, that's y, minus 16 divided by 8 is 2, and that y goes away. Well, now this is easier because at first I wasn't sure. We haven't talked about how to factor when it's a cubed. All we've done is factoring squares. So now we can say, let's look at this on the inside. 2 times -2 is -4. The factors of -4 that add to positive 3 are going to be 4 and -1. I'll grab some space here. So to write that out, we have 2y squared plus 4y minus 1y minus 2. Split that in half. GCF over on the left side is 2y, leaving us with y plus 2. The right side starts with a negative, and again, I can always pull out a 1. So when we're dividing by a -1, the signs here will change. -1y divided by -1 is positive y. -2 divided by -1 is a positive 2. That works out because now as I'm looking, y plus 2 is my new common factor. When I pull that out, my leftovers are 2y minus 1. But we can't forget to go back to our GCF that we pulled out in the very beginning and bring that into our final answer. Perfect square trinomials. Again, these are shortcuts. You can use them, but you don't have to. If you did notice that it was a perfect square trinomial, then it would factor to, you would square root each of those, and it would be those answers in parentheses added because of this plus sign here squared. And then the same thing with this one, but because the middle term is subtracted, it would be x minus y squared. Again, this is a shortcut, and you do not have to use it. So how would you use it if you wanted to? Well, I would start with square rooting the first and the last term. So the square root of 16p squared is 4p, and the square root of 25q squared is 5q. So the test is to see what is 4p times 5q. Well, 4p times 5q, 4 times 5 is 20, pq, and then double it, which was the factoring pattern up here. 2 times 20 is 40 PQ. So my last step for factoring, bring down that subtraction and then write it as squared, and that's your answer. For letter B, again, we would square root. The square root of 36 is 6. The square root of x squared is x. The square root of y squared is y. And the square root of 49 is 7. We would check, what is 6xy times 7? Well, 6 times 7 is 42, and then xy. And if I double it, I get 84xy, which matches this middle term. So we grab the sign in front of that middle term, which is adding, and then that is our factored form. This is where we're stopping for today. Thanks so much for joining me. We'll see you next time.